The following is the video solution from JSDT Solutions. Question 9 says the function f of x is equal to 2x cubed plus px squared plus qx plus 3. So immediately you see that there are two missing variables here. And then they tell us that this function is drawn and we have n and m are turning points of f. G is the y-intercept of f, and a, b, and c are the x-intercepts. And the first question is to show that p equals -5 and q equals -4. So we have two missing variables. When you have two missing variables, you usually need 2 points to find it, or at least 2 pieces of information. So here's the thing. If we look at the graph, you see that the only point we are given is n. But n is not an ordinary point. N is a turning point. So this means that you can use it twice. You can use it in 2 ways. So we're going to use n as a point, okay, as a point on the graph of f. So as the x value is 2 and the y value is -9. And we're going to use it as a turning point. Now remember that with a turning point, at that point, this is where the gradient of the function is equal to 0. The gradient is stationary. It's not increasing or decreasing like the way all these other points on the graph are. So that's what we're going to use here. We're going to use that we know that the gradient of this function, the gradient of f prime of x, at the point where x is equal to 2 is 0. And that's how we're going to get this. Okay, so let's go ahead and take our equation, rewrite f of x first. And now that we have it down, let's substitute it as a point. So in place of y, we say -9. So that's f of x, -9 equals 2 times 2 all cubed plus p times 2 all squared plus q times 2 plus 3. And simplify, and we have -9. Well, we can just transpose that. So it becomes -12 is equal to, that is 8. 8 times 2 is 16. So we have 16 there. And this becomes 4. So this is 4p. And that is 2q. Okay. Then we'll just transpose that, of course. So when you take it over, it becomes -28. So -28 is equal to 4p plus 2. And already I can see that we can make q a subject here. So let's transpose the 4p. So it's -4p is equal to 2q. Okay, and if we divide both hand sides by 2, q is simply equal to -14 minus 2p. Okay, so that is the equation we have there. We have q as a subject. And now we're going to use this information as a turning point. So we say f prime of 2 equals 0. Okay, the gradient of f at the point where x is equal to 2 is 0. So we need to derive this function first. So f prime of x is equal to, we have 6x squared plus coefficient times exponent, that is 2px, and then coefficient times exponent, that is plus q. But of course, with the exponent, we're going to say exponent minus 1, which is 0. Anything to the power of 0 is 1. And so that's why this stays the same. Okay, deriving a constant just makes it 0. And now we're specifically going to find f prime of 2. Now we'll say 2 in place of x plus 2p times 2 plus q. And we know that f prime of 2 is equal to 0 because the gradient is 0 at that point. So that's going to be 4 times 6 is 24. And then we have plus 4p plus q. Great. Q can also be made a subject here. So we can just say q is equal to and transpose all of this. So -24 minus 4p. And this is what we have. And let's equate. So we're saying that q is equal to q. So q equals q. Therefore, -14 minus 2p is equal to -24 minus 4p. Okay. Transpose this. It becomes positive 4p, and we still have the -2p, which give us 2p is equal to. And then -24, when we transpose, that becomes positive 14. So that gives us -10. And then divide both hand sides of the equation by 2. Therefore, p equals -5. And now we found the value of p as -5, like they said it would be, So to find q, all you have to do is just take one of the equations of q. Okay, this one or this one is perfectly fine. And we'll just say q equals negative 14 minus 2, and in place of p, substitute your p-value of negative 5. And we get, that gives us positive 10. So that's negative 14 plus 10. 10 minus 14 is negative 4. And there we go. So p equals negative 5, while q equals negative 4, just like they said. Moving on to the next question. Question 9.2 says, determine the coordinates of G, the y-intercept of F. Okay, now we already have the full equation, but do you see that they already gave you the equation in standard form? So we don't have to do any calculation. You see, the value without a variable, without x, that is your y-intercept. Okay, because if you try to find the y-intercept, you have to make x equal to 0. If everything becomes 0, you're only left with 3. So we can clearly see here that G is simply 0 and 3. So G is 0 and 3. And that is our answer. Moving on to the next question. Question 9.3 says, if it is given that C is 3 and 0, calculate the distance between A and B. So find the distance between A and B, the x-intercepts. Okay, and they gave us C, which is another x-intercept. So if this is 3 and 0, okay, so 3 and 0, why did they give us this? So how does that help us find these? Well, these are x-intercepts, and in order to find the x-intercept, you need to make y equal to 0. Once you make y equal to 0, you have to actually factorize this. And so what they're actually giving us is a factor. They're telling us this is one of the solutions you're going to get. They're giving us a factor and a solution. So we don't have to search for it. Okay, so let's just rewrite our equation of f with p and q being negative 5 and negative 4 first. Okay, and to find the x-intercept, we simply make y equal to 0. Now, at this point, we would need to take 3 and then start looking for factors of 3. We'd have to list all the factors of 3 and then see which ones will give us 0 when we substitute them into here. But we don't have to do that anymore since they told us one of the solutions. So we know that x equals 3, when you substitute this into this equation, it will give you 0. And so we don't have to even substitute anything. We can go ahead and continue factorizing. So I'm going to use the long division method. And to do that, we first draw an L backwards. Okay, like the capital letter L. And here we're going to put that number, okay, that one of the roots that we have, which is x equals 3. So that is 3. And now we're going to list out the coefficients. So that is 2. That's the coefficient of x cubed. And minus 5, minus 4, and positive 3. Then we drag down the 2. And then we say 2 multiplied by 3 gives us 6. 6 minus 5 gives us 1. 1 times 3 gives us 3. 3 minus 4 gives us negative 1. Negative 1 times 3 gives us negative 3. And negative 3 plus 3 is 0. You should always end at 0. And that's how you know that your factors are correct. So here are our factors. You see that we already had a solution here, that x is equal to 3. What that means is that one of your factors, when you're factorizing this equation, one of the factors is x minus 3. Okay, and then the other factors we get from here. So we're going to take this, and these are the coefficients of x squared, x, and your constant. So this is 2x squared plus x, and then minus 1. Okay, of course, this is equal to 0. So x minus 3, and factorizing this, we need factors of 2x squared. That's 2x times x give us 2x squared. Factors of 1, just 1 and 1. But this is negative. And so one of them need to be negative. Okay, so we need to make it negative, but ensure that the middle term will stay positive. So which should be negative? We need to ensure that we give the negative to not this, because this is going to become 2x. So you don't want it to become negative 2x. So we're going to give the negative to this one, okay, and give this positive. So when we cross multiplied, you see 2x times 1 is 2x, and then x times negative 1 is negative x. 2x minus x equals x, positive x, and that is our middle term. So our factors are 2x minus 1, and x plus 1 is equal to 0. Okay, so this is our equation factorized. And now we can find a and b. And we'll just find the distance. So we know already that x was equal to 3. Or here, we're going to say 2x minus 1 equals 0. Transpose that -1, it's positive. Divide by 2 is x equals positive 1 over 2. And then here, x equals -1. So we already know this belongs to C. So that's for A and B. Let's just see. There's one that is negative and there's one that's positive. So this is the -1 and this is the 1 over 2. So what is the distance AB? What is the distance of this line? You're simply just going to say the highest x value minus the lower x value. Because this is a horizontal line, you don't have to use the distance formula for this. So AB is therefore equal to, and we're just going to say a half minus -1, which becomes +1, and that is just 3 over 2, or 1.5 if you want to write it like that. And that is our answer. AB is simply 1.5 units. Moving on to the next question. The next question, 9.4, says, calculate the x-coordinate of M, a turning point of F. So one of the turning points. To find the turning point, you can take the equation of the function, and we are going to find out where the gradient is equal to 0. Just remember with your graph, at the turning point, your gradient is equal to 0. So that's what we're going to do. Find f prime of x, and let's just write this as f of x. If this is f of x, then f prime of x is, we're going to say 6x squared, okay, coefficient times exponent, and then same thing over here, -10x, and then -4. And the turning points occur where the gradient is specifically equal to 0. So we're just going to equate this to 0. So 6x squared minus 10x minus 4 equals 0. Do you see that we have a common factor of 2 all through? So we can simply divide both hand sides of this equation by 2. Therefore, we have 3x squared minus 5x minus 2 equals 0. And we need to factorize this. Okay, so again, I'm going to use the cross method here. Factors of 3x squared, 3 is a prime number, so 3x times x give us 3x squared. And then factors of 2, also a prime number, 2 and 1. But we need to structure it in a way that one of these have to be negative, so they can give us -2. But then when we cross multiply their product, okay, the sum of their product will be -5. Okay, so you see, like, this is not going to happen because one of it has to be negative. You're going to have a 3x and a 2x, but one must be negative. It's either going to give you a positive x or a negative x. So just swap these. Make this 1 and make that 2. So now we need to ensure that this stays negative. Okay, for it to stay negative, give the negative to the product that is going to become the bigger value. That would be this. So give this the negative, give that the positive. So this becomes -6x, and that is positive x, which indeed does give us -5x, just like the middle term we have here. So our factors are 3x plus 1 and x minus 2 equals 0. And solve for x. So here, x would be equal to, so equate it to 0, transpose the 1, it's negative, and divide by 3. So this is -1 over 3. Or x is equal to +2. So we already have one of them. So we just have to see which one exactly is m. This is the +2, so m is the other. Okay, and remember that they specifically said calculate the x-coordinate of m. Okay, so they just want the x-coordinates. So we can therefore tell them x is equal to -1 over 3. And that is our answer. Moving on to the next question. Question 9.5 says, determine the x-coordinate of h, the point of inflection of f. Okay, so you see we have a cubic function. How do we find the point of inflection? Remember that the point of inflection is just that point where the graph changes concavity. It changes from being concave down, in this case, to concave up. Okay, from a sad face to a smiley face. So how we find that point is we find the second derivative of this function, right? And we're going to set it equal to 0. So we could start from the first derivative, which we already found. Here's the derivative when we're trying to find the turning point, that x value, and then derive it a second time. So going to find the second derivative, and we're multiplying coefficient times exponent, that is 12x, exponent minus 1 is 1, and then minus 10, and the x falls away, of course, because of the exponent of 0 that we will have. And then we're going to set the second derivative equal to 0. So we can transpose 10 here. So we have 12x is equal to positive 10, and then divide both hand sides of the equation by 12. Therefore, x equals 10 and 12 have 2 in common. So 10 divided by 2 is 5, and we have over 6. So 5 over 6 is our answer. And that is the x value of the point of inflection. Moving on to the next question. And now 9.6 says, for which values of x will f be concave up? So we just found the point of inflection. Remember how I said that? The point of inflection is that point where the graph changes concavity. So it changes from being concave down to concave up. If we know that the point where it changes concavity is at 5 over 6, then it means that where it is concave up, where it has a smiley face, would be all these values here. So if you map these up to the x-axis, do you see that there are values that are greater than 5 over 6? Okay, so that is our answer. We'll simply just tell them x is greater than 5 over 6. Okay, moving on to the next question. Question 9.7 says, for which values of x is f of x multiplied by f prime of x less than 0? So f prime of x stands for the derivative. You can choose to either draw it, but you don't really have to. Here's the thing. F prime of x stands for the gradient of this graph of f. Let's speak about what the gradient can be. You see, if the gradient of a function is positive, then it means that that graph is moving up, okay? It is an increasing function. It's increasing when you read it, moving from the left to the right. If the gradient is negative, then we will have a decreasing function, okay? So it's moving down if you read from the left to the right. So how you can just see this is they're asking you, for which values of x will you have f of x? F of x stands for the y values of f. So where will the y values of f multiply by the gradient of f be negative, less than 0? So let's look at the possibilities. If we want to get negative values here, we can either look for places where f of x is positive, and then we multiply it by f prime of x, which is negative, then you would get a negative value, a value less than 0. We could also look for places where f is negative, okay, f of x is negative, multiply by positive values of f prime of x, and then we would also get a negative value. So we're going to look for these on our graphs. Okay, so here is our graph, and we are looking for this. Remember, f prime of x being positive, or let's start with negative. If f prime of x is negative, all this means is that this is the place where the graph is decreasing, because decreasing functions have negative gradients. Okay, so let's look for the places where first, it'll be easier to work with the f prime first. Okay, so where is the graph of f decreasing? If you read from left to right, here it's increasing. And then here it starts to decrease. And then it starts to increase again. Okay, so it decreases all through here. And you can see that the critical points we need to mark would be these turning points. Remember that this one was negative 1 over 3. Okay, this is negative 1 over 3. So this is where it's decreasing. Now, for the same x values, we need to make sure that f is positive. Okay, so the y values of f must be positive. Let's speak about where y values of f are positive. They're y values, so they relate to whether they have positive or negative values. Okay, positive values on the y-axis are over here, so that is everything above the x-axis. Okay, these are all positive y values. If you find these points and you map them to the y-axis, they all have positive y values. So we need to ensure that the graph is decreasing, and at the same time, the graph of f has positive y values. where will that happen? That would be, and I'm just going to get the section eraser quick, that would be here. Do you see that here the graph is below the x-axis? It has negative y values, so we don't want that. So where it has positive y values and is decreasing would be this little section over here. Okay, for that it meets both criteria. So to answer them, what is this? Well, the x value here is negative 1 over 3. And the x value here, what is that? We can see that that is an x-intercept. And the second x-intercept we had was b, okay, which is that 1 over 2. So this is where x is greater than negative 1 over 3, but less than 1 over 2. Great. So this criteria has been met. We found that. Now looking at this one. Again, you can focus on where f prime of x is increasing first, where it has a positive gradient. So where does it have a positive gradient? Where it's moving upwards. So here it's moving up, and here it's also moving up. For the same x values, okay, or at the same time, we need to ensure that the graph of f is negative this time. So where the graph of f is negative or has negative y values, this will be below the x-axis. All the negative y values are here. So we see that we can't take any of these parts. We can't take this because that's above the x-axis. We can't take that. That's also above the x-axis. And we can only take everything below here. Okay, so we can see what we need to take now. It's just all of the parts that have been selected. So you can line that up to the x-axis and you see which values these are. So this is negative 1 here at A. And so these map to values that are less than negative 1. So here, x is less than negative 1. And here, what are these values? Well, they start at 2, or really just immediately after this x value of 2, because this is the x value we have here. And then there are all these values. When you map them up to the x-axis, do you see that there are values that are greater than 2, but then they stop, okay? Values that are greater than 2, but less than 3. So that will be our answer this side. So here, x is greater than 2, but less than 3. So do you see from this, we have 3 sets of solutions. This is a solution, this is a solution, and this is a solution. So we're going to have to write all 3 of them. I'll start with this one because it's more on the left, and then this one, and then that one. Okay, so our answers are x is less than negative 1, or x is greater than negative 1 over 3, but less than 1 over 2, or x is greater than 2, but less than 3. And that is our answer, and that is it for question 9.